Hi, everybody. This is Ray Ranella from Soaring Eagle Consulting. I'd like to welcome you to today's webinar, Indexing for Speed, presented by author, lecturer, consultant, and database expert Jeff Garbus. Jeff is also the CEO of Soaring Eagle Consulting, a firm that's been helping organizations of all sizes and industries address their most challenging database needs. As a consulting firm, we focus on all the major database platforms, including SQL Server, Sybase, Oracle, DB2, and some others. In addition to performance optimization, we help our clients with architecture and design, scalability and planning, upgrades, migrations, as well as business intelligence. In addition to the consulting work we do, we also deliver a wide range of database-centric training classes. This session is an excerpt from one of those 40-hour classes. Finally, we provide remote database administration support where we help DBAs do their jobs better each and every day and improving their quality of life. I'd like to now introduce Jeff Garbus, your presenter today. Jeff's been working with database technology for more than 20 years and as such is an acknowledged expert in the field. He's also written 17 books on the subject with an emphasis on SQL Server and Sybase. Please sit back and relax while Jeff shares some extremely valuable information about indexing. Also, be sure to enter your questions as we go along, and we'll take time at the conclusion of the session to address as many as we can. We will also be recording this session, and it will be available sometime in the next 2 weeks on our YouTube channel, so be sure to look for it there. That being said, Jeff, please take over.
Thank you, Ray. Good morning, everybody. Thank you for sharing the next hour with me. Oops. I have a new presentation that we're working on. The animation is here, and I'm going to be stumbling a little bit. So if I don't click on something, or if I click on something I'm not supposed to, don't sweat it too much. I will get to where I need to be very quickly. So, topics for today. We're going to be talking about indexes. So this seminar will talk about everything you wanted to know about indexes but didn't know who to ask. Topics include how the optimizer chooses to use an index or chooses not to choose an index. How the indexes work with search arguments. A SARG is a search argument. That is something that we use to restrict the number of data rows coming back from the database. So if we've got 1 million rows in the database, typically we want 1 or 2 or 50 of them. We don't want the whole million. We'll talk about clustered versus non-clustered indexes. That is one of the most important things that you'll be getting out of this particular seminar. We'll talk about how OR works with search arguments in the optimizer versus an AND. We'll talk about index covering and forcing index selection. The server has 3 basic search techniques. The first one is a table scan. A table scan means that we start from the top of the page chain and work our way all the way to the end of the page chain. This will get us every row of data in the table. It is the most efficient approach to getting the data out if you want all the data. However, if you want a single specific row, table scanning a 10 or 20 million row table is usually not your first choice. Your first choice generally is going to be the index search. The idea behind the index search is we take a B tree that we have created, we enter at the root level. We enter at the root level, and from the root level, we traverse the tree until we get to the data page. We will go through that one graphically, by the way. Finally, we have a tool called a covered index search. The idea behind the covered index search is we will take the leaf level of a non-clustered index and treat it as if it is the data page of a clustered index. And we'll talk about that one in a little bit. So if the server can't handle a query in any other way, it does a table scan. Let's say that a different way. A table scan will be performed A, when it is the best way of getting at the data that's been requested, or B, when the server is unable to resolve the query any other way, or C, when the other approaches to resolving it become more expensive than the table scan. Sorry, still working with the clicker. So here's a sample of a table scan search. We're selecting from a table where the ID is equal to 1, but this particular table does not have an index on it. How do I know that? Because it's my table. The query plan looks like table scan. We can verify table scans, and I verify a lot of things with set statistics IO on. The idea behind set statistics IO on is that we instruct the server to tell us how many passes it's making through the table and how many total page requests that costs us. Don't worry about too much of the rest of it. You really don't care about physical reads or read-ahead reads. Read-ahead reads are a good thing. Physical reads obviously are a bad thing, but in a real production environment, you never know what's going to be in cache and what isn't. So in general, I tend to look at the logical reads or the number of page requests in order to resolve a query. This particular page, this particular table scan cost 38 page reads. So there are 38 8K pages that got read in order to resolve it. An interesting point here is that it is not just a select that can cause a table scan. An update can cause a table scan. In this example, we're updating a table. We're incrementing the IDs. What we're doing here is forcing the table scan. Note that the table scan is about 80% of the cost of the query, and the table update itself is about 20% of the cost of the query. Reason for that is that we're not writing as much as we're reading. What we're really doing is writing the changes to the log. The updates to the log are very quick. A couple of other interesting things bring themselves to the forefront of your minds when we're starting to look at this query. First, what happens when we don't have a useful index for a query? Answer, we're going to create a lock on the entire table for the duration of the update. Today, hardware masks a lot of bad things. Let's say that a little bit differently. You may have hardware that's fast enough that your 20 million row update is happening in 2 or 3 seconds. The people that are using your system may be used to 2 or 3 second response time, and as a result, they may not complain about it. But here's the thing. If you're going to be creating a table lock that lasts for 2 or 3 seconds, what is the effect on the rest of the application? Well, if you have 5 users on your system, it may not matter. If you have 50 users on your system, they're going to start to see some blocking. If you have 100 users on your system, you may start seeing a lot of deadlocks. This actually was an issue that woke me up on Friday night of this past weekend. I got a call from a client who was experiencing about a third of their transactions deadlocking and crashing, and it turned out that they had an update without a matching index. It was table scanning a 20 million row, was putting a table lock on there. We went from, it was in the neighborhood of 300 deadlocks per second, down to 0 deadlocks per second by adding an index on the correct column. Sometimes it's the little things that make a really big deal of difference. Oh, one other point while we're on that particular slide. What this is doing is it's incrementing all the IDs. So let's say, just for the sake of argument, we've got IDs of 1, 2, and 3, and we have a unique index on them. Let's forget about whether it's clustered or non-clustered index. Not really relevant. We have a unique index on there. If we say, let's change all the IDs from 1, 2, 3 to 2, 3, 4, are we going to blow up when we change the 1 to a 2 before we even get to change a 2 to a 3 or a 3 to a 4? At update time, the SQL Server has an approach called a deferred update. What the deferred update does is it says, let's identify all the changes, and then prior to committing the changes, let's test the constraints. So from a technical perspective, this will occur. It will do a little bit of extra work because the deferred update is a little bit more expensive than the direct update, but you will get there from here.